We are continuing on with our absolute value. We're moving into the inequality portion. So things to note. Absolute value inequalities. If we have less than, or an absolute value is less than, or an absolute value is less than or equal to, then we have an and statement. So this would be, there it is. We would write this as, because remember, absolute value has two options. Our negative option, A, that's what I'm going for here, and our positive option. Now, they will either both be less than or both be less than equal to. You won't have one less than, or equal to. And then our graph will be, we have negative b, 0, and positive b. Our graph will be our Baymax eyes, where we have the two circles and the line connecting them in between. So less than is an and statement. We are being inclusive and including everyone. Greater than is we think we are better than everyone, and so it is an or statement, and we have A is, and then because this becomes a negative B, we flip our symbol. So less than negative B, or A is greater than positive B. So again, because it becomes a negative B, we flip our symbol to become less than. And our graph, we have negative B, 0, and B. Our graph will be our two dots, or two circles, and going away from each other. So, absolute value inequalities. Like equations, we have two answers. And if it's the less than or equal to, we have an and statement. If it's greater than or equal to, then it's an or statement. And let's do our example. All right, so what are the solutions to the absolute value of 8n is greater than or equal to 24? So because it's greater than, I know it's an or statement. So I'm going to rewrite this. I have the first thing I would do is make sure my absolute value has nothing on the outside. So I don't have a plus or minus anything on the outside, and I don't have a coefficient. So from here, I'm just going to have 8n is, now for my negative, I'm going to flip it, less than or equal to negative 24, or 8n is greater than or equal to 24. And then from here we solve. Divide by 8 for both equations, and n will be less than or equal to a negative 3, or n is greater than or equal to a positive 3. And then we graph. I am lazy, so I'm just going to put negative 3, 0, and 3 on my graph here. It has the equal to, so they're solid circles. Got our closed circles, and it was greater than, so they are going away from each other. And that is our last example. I say it's our last example, but evidently I am missing a page, so that's great. We'll do one more. Here's a less than. 2x plus 4. The absolute value of 2x plus 4 is less than or equal to 5. So absolute value, nothing's on the outside of the absolute value, so I split it. It's less than, so this is going to be an and statement. So I'm going to write it negative 5 is less than or equal to 2x plus 4 is less than or equal to positive 5. From here, I am going to subtract 4. Remember, on our compound inequalities, if it's an and, we subtract it from all places. -5 minus 4 is -9, less than or equal to 2x, because our 4's become 0, is less than or equal to 1. And then we're going to divide everything by 2. And so now we have a -9 halves is less than or equal to x is less than or equal to 1/2. And so from here to graph it, I'm going to have a -5, a -4, 0, and 1. And so we're between 5 and 4, -5 and -4, and we are between 0 and 1, and we draw our line between the two, which, like I've said before, makes me think of Baymax's eyes. And so that's our graph. And I am definitely missing pages, so who knows where all these went. A company makes boxes of crackers that should weigh 213 grams. A quality control inspector randomly selects boxes to weigh. Any box that varies from the weight by more than 5 grams is sent back. So what range is allowed for weights of boxes of crackers? So we should be 213. I'm going to subtract my actual weight. And so positive or negative, that we're just going to do the absolute value of that. And then we have to be, any box that is more than 5 grams is sent back. So we want to be less than or equal to the 5 grams. So we're going to call the actual, we'll call that W. So 213 minus W has to be less than or equal to 5. And so this is our absolute value. Since this is less than, we're going to have a -5 is less than or equal to, and I put a line where I didn't need a line. All right, less than or equal to 213 minus W, less than or equal to 5. So I need to get rid of my 213, so I'm going to subtract all sides by -213. Here we're going to add, so we're going to get a -218 is less than or equal to W is less than or equal to, here we're going to subtract, so that would be a -208. I had to think there for a second. I dropped, see, I made a mistake that you guys tend to make. I dropped my negative, but I need to put it back. Now I'm going to divide by that negative. Otherwise, it wouldn't make sense to have negative weights. But we had that minus W, so I don't want to make sure. I want to make sure I don't drop that out. So we need to be between 218 pounds, and we divided by a negative, so that means 218 is greater than or equal to our W is greater than or equal to 208. So we need to be between 208 grams and 218 grams. That's what we want to be between. And now let's see, do I have another one? No, we actually made it to the end. So biggest thing, absolute value. Less than is an and statement. Greater than is an or statement. And then it's the same steps that we did with compound inequalities. So that is it. Until next time, 8th graders.